Good morning and hello everyone. Once again, we meet again. Remember me, your science teacher, Mr. Mofokeng. Grade 7s, remember these lessons are brought to you live by SmartCaps, and they are in line with the Department of Basic Education, in line with CAPS, and in line with the revised annual teaching plan, meaning you are on course. These are proudly brought to you by the Department of Basic Education, by VT Africa Holdings, and companies. This is where you can interact with me by logging on to hellosmart.com. You're going to be able to take part in our assessments. You're going to sign in as a guest and you're going to use this class ID. You will see as you log in, you'll be required to enter class ID, which will be 598751. You add your name and we interact. So we've been talking about matter and materials, and this is one topic that I find hugely interesting, and it makes a great chunk, it takes up a great chunk of our sciences and chemistry. So it is a very important chapter, matter and materials. And in our last lesson, we were talking about, in this lesson, we're going to be talking about mixtures. In our previous lesson, we were talking about properties of materials. And in this lesson, we are going to talk about mixtures. So when we're talking about mixtures, what comes to mind when we're talking about mixtures? When we're talking about mixtures, we're talking about two or more substances that come together to form one particular substance, right? We're going to take two or more substances. We're going to take salt, and we're going to take water, and when we mix these together, we form a mixture. These, when we're mixing two or more substances, we form mixtures. When we two or more substances coming together form a mixture, right? So we have different types of mixtures, and before we talk about different types of mixtures, there's another term that I'd like us to look at, which is solutions. When we're talking of a solution, there's a great difference between a solution and a mixture. Solution and a mixture. And I'd like us to get to define these, get the difference, understand the difference, and only then do we continue to understand the different types of mixtures that we have, what we can do with them, and how they benefit us. So when we're talking about solutions, we're talking about two or more substances coming together and reacting chemically to form one solution, to form one mixture. So two or more substances reacting chemically. So they are reacting chemically to form one solution, right? To form one mixture. But in terms of a mixture, they do not react chemically, but they are mixing together, but there's no chemical reaction taking part. Here, we are talking about two or more substances coming together, but there's no chemical reaction between the components that you have mixed, between the substances that you have mixed, no chemical reaction. Right? So this is of great significance to say in a solution, there'll be a chemical reaction. And with a mixture, there's no chemical reaction. Let's think about it. When you are mixing salt and water, you're putting salt and water in a bowl. And there you are adding your salt. Your salt will suspend, or your salt will float in your mixture. And this here, there will be no chemical reaction that takes place in this mixture. And that there tells us what? It tells us this is a mixture than a solution. This is a mixture than a solution, right? Because there's no chemical reaction that takes place between the two. So when we're talking about mixtures, which will be what we'll continue to discuss, we're going to discuss mixtures as well as different types of mixtures. So as we continue to discuss mixtures, there'll be a few keywords that we'll need to take part of or remember, try to remember. In this chapter, we've already defined mixture. We'll come upon a word called suspension, opaque, solution, and clear. So we've already discussed what a mixture is. We've already discussed what a solution is. Let's discuss suspension, opaque, and clear. When we're talking about opaque and clear, what are we talking about? When we say something is opaque, we mean that upon trying to look through the substance or looking at the substance, it is not easy to see through the substance. When we say, when that substance is hard, it's difficult to see through, we say it is opaque. An example can be a tinted window. We say it's opaque. And another example can be a solution of sugar and water. When you look through a solution of sugar and water, you'll see that it is a brownish substance that comes through. A brownish substance that you find. The substance will come like this, and trying to look through this, you'll find that it is difficult to see what is beyond this. And we hence say the substance will be opaque. There will be disturbance or distraction in trying to look through or see through the substance. And when you're mixing something else, say salt and water, it can be easier to see through the substance because it will be clearer. And that's when we say solutions are clear, right? For solutions to be opaque, what makes solutions to be opaque? For solutions to be opaque or difficult to see through, it will be because we'll be having our solution as well as suspended or floating particles inside a solution. Suspended or floating particles inside a solution. And these suspended or floating particles will make the visibility much harder, meaning it will be harder to see, right? You can, as you see on the board, this is a solution of water and sand, or water and soil. So water and sand or water and soil will give a solution that is very difficult to see through. And that there we'll call a solution that is opaque. And we'll have a solution that is now clear, where we are mixing salt and water. So we now know what the mixture is. We know that the mixture is two or more substances coming together to form a solution, right? We know that we have suspension being particles in our mixture that are floating in our mixture. We say we have particles suspending in our solution, and those particles suspending in our solution make the solution what? They make our solution opaque. right? It is difficult to see through these solutions. And when we do not have our solution as opaque, we have it as clear. Easier to see through. So let's look at different types of solutions that we have, right? We have different ways or different substances that we can mix together. And when mixing these together, we find different things coming out. Let's start off with mixing a solid and a solid. What happens when we mix two solids together? We find ourselves with one new substance that is now a mixture of two independent substances, right? Yes. So it so happens that when we are making metals that are called alloys, a new term to your vocabulary, when we are making alloy, what are alloys? Alloys are mixtures of two or more metals. Mixture of two or more metals. When we mix two or more metals together, we find alloys. We are going to take one metal melted, take another metal melted, and mix the two. That gives us a new mixture that has two solids mixed together, right, to form alloys. It doesn't need to be melted because then you'd be having a liquid, but the metals being able to be mixed together give us alloys. And what do we do with alloys? Alloys now enable us to have a new material that has more characteristics. You remember when we were doing characteristics of materials that allow us to have one metal with more characteristics. Say we're trying to improve the conductivity, or the electrical conductivity or the heat conductivity of a particular metal. We can add another metal onto that metal to make an alloy or metal mixture, such that we have more pronounced or better characteristics, right? And that's what we do when we mix two or more metals. Remember, metals being solids. That's when we'll be mixing two or more solids to give us a mixture of a solid and a solid. An example being alloys. We create alloys in order to create a metal that has more or better characteristics suited to what we're looking for. Awesome. What else can we do? We sometimes mix solids and liquids. And in our households or in our homes, we find these solutions being quite predominant. We do this all the time. We mix solids and liquids all the time. Let's think of examples. What happens when we are mixing, when we mix sugar and water? When we mix sugar and water, we'll be mixing liquid. We'd be mixing liquid, which is water, and we'd be adding sugar, right? When we mix sugar and water to find a solution, because now we are mixing two substances together. Those two, because they are not reacting chemically, they come together to form a solution, right? Let's take salt for an example. Salt, best example. Water and salt. When we mix also water and salt, we find a solution, salt water, or brine, as others would have it. And these two allow us to have a solution that we can use in many different ways. I'm sure you can find other examples, and in our activity, we're gonna have more examples coming together. We're gonna answer questions regarding more examples on different mixtures, solid and liquids, solids and solids as we go on to find more examples of liquids and liquids. Let's try to look at more example of mixtures. Here we have an example of a mixture of a solid and a gas. A solid and a gas. If you've ever been exposed to smoke, you'll find that it is very affecting to your lungs and your coughing and your breathing. Why is that? Smoke looks like air. Why is it that it affects our breathing and smoke, our breathing like that? It's because smoke is a mixture, right? A mixture of air and suspended particles. Suspended particles. You remember the word suspended? It means floating in suspended particles. So what are these particles? When you have smoke, those particles can be anything. It depends on the fire. So what you'd be burning, it will either be paper, it will be wood, it will be whatever you have there, it will be ash. So ash would be suspended in air to give us smoke. And what would that be? It would be gas, which is the air. It would be gas, which is the air, as well as the suspended particles, which is ash, which would now constitute as the solids in our mixture. We'd be having a mixture of gas and solids, and that would be giving us smoke. That's one other type of a mixture, when solid meets a gas, right? Let's look at what happens when let's look at other mixtures that we can find. When you're trying to make a nice Kool-Aid back home, say Oros and water, you'd be mixing two liquids together, right? When you're making your tea, you can add milk to mix two liquids together. So let's look at one other example, milk, which is a very important example in our mixtures. When we're looking at milk, what's milk? Milk is a combination of water and fat. Water is a mixture of water. Milk is a mixture of water and fat, or you can say fatty oil. Where these two are both liquid and liquid, coming together to give us a mixture of two liquids, which is milk, another type of mixture. So we know that mixtures can be a solid and a solid and a gas, a liquid and a liquid. Mixtures can be a combination of a variety of substances. Here we are having a gas and a gas. When you're trying to mix two gases together, yes, they can come together to form a mixture. You can take one substance that is a gas, take another, put them together in a chamber to form a solution, a mixture, right? The air that we breathe is made up of what? Components of different substances. It's made up of nitrogen, it's made up of oxygen, it's made up of carbon dioxide, and many other gases. But these are those that are predominantly there. These are those that are there in great number. And when they are there in great number, I'll introduce a new term to you to say they are in abundance, right? They are in our solution by great numbers. So that is when we're mixing gas and a gas. Here we have nitrogen together with oxygen, together with carbon dioxide, coming together to form air, right? Where air is a mixture of all these different gases, right? That's awesome. And sometimes when we are looking at the sky, we see clouds forming. What are clouds? Clouds are simply vaporization. Clouds are essentially water vapor. So water vapor would be in the air as gaseous water as well as air, forming a cloud. Meaning a cloud would be a mixture of vapor and air. That's another example of when mixtures are made from a gas and another gas. So we have all these mixtures coming together to give us different types of mixtures coming together, right? So when we have these different mixtures being able to come together, we have different types of mixtures and we use this in different ways. So I'm going to have examples on the board and we're going to discuss as to this being a mixture, this being a solution, this being a mixture of what and what. So when we have something like oil, we know that oil is a mixture of different substances, right? Can we say this is a mixture or a solution? Mixture or solution? We have come to define these two terms, right? Mixture or solution. We know that the difference between the two has to be that one has chemical reaction between the components. They are chemically bonded, whereas here there's no chemical reaction. So when looking at substances such as oil, we know that we have a solution or a mixture where the components have been chemically bonded together, making it a solution rather than a mixture. Let's look at another example. When we are having plastic. Plastic is a substance that has different other material in it. In plastic, we know that we have materials that have been chemically bonded to each other, meaning plastic does not make a mixture, but also makes a solution. Plastic is a solution as well. Let's look at another example. When you're having seawater, if you go and pick up seawater, what do we have in seawater? We have water, we have salt, and other suspending materials. So seawater will come and form part of a mixture, right? Because these are chemicals these are components or substances or materials that are not chemically bonded to each other, right? So this brings us to a topic that we'll be discussing in our next lesson, separation of mixtures. Separation of mixtures, where we will be looking at, now that we know how we can mix substances together, we can mix solids and solids, gases and gases, gases and solids, liquids and gases, however mixture we can think of. Now that we can mix separate substance together, how can we now take a mixture and break it apart into its constituents or into its components? We're going to be looking at those separation of mixtures. There are different ways to separate materials. And if it's a mixture, we know that they are not chemically bonded to each other. No chemical reaction. So given that there's no chemical reaction, what does this mean? It means we have a physical separation. We have a physical separation when we are dealing with mixtures, different from when we are dealing with solutions. When we are dealing with solutions, because they are chemically bonded together, or there's some form of chemical reaction between the components, it means that the separation of the solution will need chemical reacting or chemical reactions. So with mixtures, because there's no chemical reaction, the separation can take part as a physical separation. And in our next lesson, we'll be discussing what physical separation is, separation of mixtures, and different types of separations. And that brings us to a draw. In today's lesson, we know what a mixture is. We know that when two or more substances come together and there's no chemical reaction and they form one solution, we call that a mixture. We have learned that when two or more substances react and they react chemically, we know that we call that a solution. We know the different types of mixtures that we have. When we're mixing different substances, we find different combinations. We know how we can combine different materials in different ways now to give us new materials that can be better used, or where properties can be better enhanced, right? And we found that we have, when we're mixing solids and solids, gases and solids, gases and gases, liquids and liquids in many different ways. And we've looked through examples. And as of tomorrow, we're going to start with an activity on these, small activity, and we'll continue with separation of these mixtures. And for today, that is it. Thank you, grade 7s. We'll discuss more in our next session. These lessons are brought to you live by the Department of Education, and they are in line with the revised annual teaching plan, and they're live brought to you by Vastra Tech. So in the next lesson, you'll be connecting to Hello Smart and be able to interact with us. Thank you.